Tape's rolling. I don't know when that's going to happen. Sunrise semester, Astro number 14. Take one.
Sunrise Semester, produced in association with Washington Square College of Arts and Science at New York University, presents The Heavenly Twins, Astronomy and Astrology, with Professor Engelbert L. Schücking.
We had discussed the last time the orbit of the Moon, and I had mentioned that this orbit is not exactly coincident with the ecliptic, but is inclined by an angle of about 5 degrees. We had learned that the intersection of the great circle of the Moon's orbit and the great circle of the ecliptic are called the nodes, the ascending and the descending nodes, and we will therefore find the Moon in the ecliptic only if the Moon is either at the ascending or at the descending node. If the plane of the lunar orbit was coincident with the ecliptic, we would have an exact line-up at every new moon and at every full moon of the three celestial bodies of Sun, Earth, and Moon. And we would have then, in this case, at every new moon, an eclipse of the Sun by the Moon, a so-called solar eclipse, and during every full moon we would have an eclipse of the Moon by the Earth, which is called a lunar eclipse. However, since the lunar orbit is inclined towards the ecliptic, in general we will find that the Earth is not hit by the shadow of the Moon when the Moon is new, and that the Moon is not hit by the shadow of the Earth when the Moon is full. Only in the peculiar position, if the Moon happens to be near one of the nodes, we can get a perfect line-up, and then an eclipse of the Sun or an eclipse of the Moon can take place. We want to look at this configuration of the slides. You see here the equatorial belt, the ecliptic, so we have a ecliptical coordinate system, and this thing that is called here NCP is not the North Celestial Pole, but the ecliptical pole. People who draw slides are not perfect. This is the Earth in the center, and here is the Moon's orbit, inclined by 5 degrees, and here is the ascending node. The opposite point here is the descending node. We wish to see then how the configuration of the Earth, Sun, and Moon can give rise to eclipses if the Moon happens to be near one of the nodes. In this very rough picture, you see the Sun at the left and the Moon casting a shadow, the tip of which just reaches the Earth. Now, that eclipses can occur is solar eclipses is due to the fact that Moon and Sun approximately have the same size. This shadow cone will not hit the surface of the Earth if the Moon is further away from the Earth, if the Moon is in its apogee. Now, if the Moon is close to the Earth, then this shadow cone will cut out a piece on the surface of the Earth that is large enough so that somebody who stands there will see the whole Sun eclipsed. The diagram below shows you how a lunar eclipse occurs. The Sun again to the left, and the sizes and distances are certainly not drawn to scale. The orbit of the Moon goes like this, and here we have the shadow of the Earth, and if the Moon gets into this shadow, it will be eclipsed. And that happens at the time of the full moon. Now one has to look at it in a little bit more detail to see how this comes about. To the right we have the Sun, in the middle is the Earth, to the left is the Moon, and you have here the course of the Moon, and the cone is the so-called umbra, the shadow of the Earth. That is, if somebody stands here with a moon or a satellite or an astronaut, he or she will not be able to see the Sun at all. If somebody stands here in the penumbra, then the Earth will obscure only part of the Sun. That is, sun rays can get to this point by passing the Earth in this way. And so you will not notice very much, because the light of the remaining portion of the solar disk that is visible will be bright enough so that no large effect is caused. The next diagram shows this in a little bit more detail, and there we have to qualify what I said before. In this case, the Sun is to the left, and you see now here the Moon in the umbra. But what I said left the atmosphere of the Earth out of consideration. Light rays of the Sun can go through the atmosphere of the Earth and still being bent around and scattered and reach the Moon, but they have then gone a long way through the atmosphere of the Earth. And you know that light rays that have a long path through the atmosphere of the Earth are filtered out. That is, the blue part of the light is being scattered away and makes the blue of the sky, while the red part comes through, and that is the reason why we see the rising or setting sun to be red. Now on the Moon, in the shadow of the Earth, lunatics or astronauts will see a very red ring round the Earth that illuminates the Moon, and therefore the Moon during a lunar eclipse will not be entirely blacked out, but will glow in a sort of reddish light in general, and depending on the conditions of the atmosphere. Here we have a picture of a solar eclipse. To the left is the Sun, and the Moon goes between Earth and Sun. You see that only somebody standing at the tip of this cone will see the Sun completely blocked out. Somebody standing here in this wider cone that will see only part of the Sun obscured, and therefore the effect will not be particularly dramatic because the sunlight is just diminished a little bit. The next picture shows you here the relation of the ecliptic and the Moon's orbit. You see in the upper part of the picture the sun on its racetrack, the ecliptic, and it moves from west to east with respect to the stars. Here is the moon going along its lunar orbit, which is inclined by 5 degrees towards the ecliptic, and you see that this is approximately drawn to scale. Sun and moon both about half a degree wide, and they are both heading now for a get-together here at the node. This picture shows the position of these two bodies a little bit later. The moon and the sun come more closely together, and here they meet exactly at the node, and the moon is therefore in front of the sun for a particular point on the Earth. You have, however, to consider that the moon will be seen in different directions in the sky depending on from where your vantage point is. This is a phenomenon of parallax, and we said that a vantage point at the equator or at the pole makes a difference in the position of the moon by about 1 degree, which is twice the diameter of the moon, and therefore solar eclipses can be seen only from a very small, total solar eclipses can be seen only from a very small area of the Earth, while lunar eclipses can be seen from half of this planet. Here you see the effect that the distance of the moon makes. The sun here to the left is on top, and the moon is in its perigee. Therefore, the shadow that it casts onto the Earth is larger. Here the moon is in the apogee, and there you see that from those points, even directly below the moon, you can still see the outer part of the sun, and therefore the eclipse will only be an annular eclipse. If the moon is directly in front of the sun, it will not blacken out this outer rim, this annulus of solar light, and again, this is not such a spectacular phenomenon as a total solar eclipse. We have here a picture of a lunar eclipse, which is taken with a camera whose light, which was exposed every few minutes or so, and you see first of all in the upper left-hand corner the moon full, and as you go down, as it becomes later and later and the moon sets in the west, you see that the light of the moon is more and more diminished till it is almost completely blacked out. Here you have in this picture Saturn, which was to the upper left of the moon, further up in the ecliptic, and so you get again here various position for Saturn. The first picture is not so very bright because the light of the full moon overshadowed the picture, and so the photographer had to take a smaller time of exposure. Now, this is the begin of a lunar eclipse. The shadow, the moon moves from west to east with respect to the stars, is anti-clockwise, as we have stressed many times. To the left of the picture, you see the shadow of the Earth, that is the umbra, and the moon is now going to move from right to left into the shadow of the Earth. This is a little bit later in the sequence. The shadow has eaten itself into the moon. The monster has begun to swallow the moon. And again, now 2/3 of the moon has been blacked out, and here more than half of it, and we go on, more, takes several hours for such a lunar eclipse, and the moon becomes smaller and dimmer, and now this is a total lunar eclipse. The exposure time is longer here, so that you might think that the moon is not totally engulfed in the shadow, but you see now a star next to the moon that you could not see on the previous photographs, and here is this reddish part that is the moon illuminated through the atmosphere of the Earth. And let us watch now the progress of this eclipse. Now here even the star has gone closer to the moon, or the moon has been moving from right to left, and so soon it is going to occult the star. And we go on with the eclipse, and this is taken with a different camera, where you see now a larger field with more stars in it. And here again, a picture taken with a longer exposure time, where the moon is totally eclipsed and the stars have come out, and it is no longer completely blocking out the light of the stars by its own light. And this sequence shows you the end of the eclipse. The moon is setting here. It is emerging from the shadow of the Earth, and you see how the bright part of the moon becomes larger and larger. Well, this is an ancient representation of lunar and solar eclipses. You see the sun in the center, and here to the right you see a representation of the of a lunar eclipse. This is the Earth, and that is the moon in the shadow. To the left you see a representation of a solar eclipse. It is not drawn to scale, and around it is a zodiac and the symbols for the planets. Another representation showing you the sun to the right, showing the Earth in the center, and showing the moon being eclipsed here in the shadow of the Earth. We have then now the dragon depicted with the orbits of the moon and the orbits of the sun, that is the ecliptic. And these two orbits, as we know, are inclined towards each other by an angle of 5 degrees. And here is node number 1 with the head of the dragon. Here is node number 2 with the tail of the dragon. And we have some more dragon pictures. This is a picture with the zodiac, and there are 2 dragons in this picture. Here is dragon 1, the right is dragon 2. You have the sun and you have the moon. In the center of the Earth, here is another dragon that tries to swallow the moon. Here it takes place in the sign of Gemini, and here is another dragon riding in the skies, and people praying because eclipses were generally thought as ill omens. Here are 2 dragons going at the sun and with their tails at the moon and the zodiac, with a castle on the Earth in the center. And here is again another dragon, a fierce one, who has swallowed the moon. This is a picture of an eclipse, and people try to do something about it. This is probably was from Peru. This one is an English representation that shows the terrible things that can happen during eclipses. This is a painting of the 1923 eclipse, and we have now a sequence of the pictures taken from Voyage to Darkness. That was an eclipse that took place last year from the movie that was made. We have here some ancient representations of the evil spirit that tried to gobble up the celestial bodies. Here again a representation of the terrors and the wonder connected with eclipses. The astronomers are naturally very active during these stages. Here we see one of their huge telescopes directed into the skies. And here again, firing of guns, an operation that has frequently been employed to again try to avert the cosmic catastrophe. Here you see from the 1972 eclipse the beginning of the totality. One has to protect one's eyes. The projection method is very good. Here the shadow of the moon has almost eaten up all of the solar disk. You see still the reflection of the sunlight with the ocean, and soon the totality will appear. You see the last stages. The moon gets before the disk of the sun, and this is the solar corona, a very hot gas, a temperature of 1,000,000 degrees that surrounds the sun. This eclipse had a totality of only about 1 minute, I think, and we see here in another shot of the 1972 that shows the outer parts of the corona with streamers, particles and magnetic fields. Here again another shot of the blocked out light, and here another one that shows the inner parts of the corona. The eclipse is also used for observing these prominences, huge clouds of gas that are ejected from the sun and then can be observed as red flames that seem to come above the rim of the sun. Again, the picture of the solar corona, and another picture that shows you this ray structure which changes depending on the solar cycle. And here the sun reappears again to the right at first because the shadow of the moon moves from right to left. The eclipse has been observed successfully, and people have added a strange experience to their lives. We have another eclipse coming up this year on July 10th, which will have a totality in some places of about 6 minutes, and I like to show you in a simple demonstration what it is going to look like. The Earth will be on June 30th in approximately this position. This ring would demonstrate the ecliptic, and the moon is here taken as a orange on a knitting needle, and the moon moves about the Earth in this way. It will be then in the descending node, and things are slightly complicated because while the moon moves in front of the Earth also rotates. But the moon moves faster than the Earth rotates, and therefore the shadow goes from west to east. So it's first seen here at sunrise and starts in South America, and the moon is a little bit above the ecliptic and will go below the ecliptic during this course. Now let us try to demonstrate what happens. You will see the shadow of the moon go here along the equator, and it goes then into the southern hemisphere. It cuts across Africa and ends at sunset in Madagascar. We have a description of the path of the total eclipse of June 30th here on this card that is taken from the American Ephemeris and Nautical Almanac, that shows you here out the zone of totality in which you can observe the eclipse. Here on the left you can observe the eclipse at sunrise, when the Earth is when the shadow of the moon first hits the Earth, and here to the right now the shadow has gone to the east side of the Earth. The Earth has rotated a little bit, and then we see the end of the eclipse at sunset, and many expeditions will go out to observe this spectacular eclipse. Now, these eclipses are not the only occasion where something comes in front of the sun. We have another picture here that shows another object in front of the sun, that is Venus in front of the sun. It's a very moderate form of eclipse, but it is an eclipse that does not occur very often. This was taken in 1882. The expeditions have been sent out in the past to observe the eclipse of Venus, and they have been astronomical events of a spectacular, on a spectacular scale. Expeditions have been sent out all over the world. One went out in 1761, one in 1769, and these events occur in a sequence of 8 years. The last one was 1882. The one before was 1874. If you want to observe the next Venus transit, you have to be patient, and you have to live long, because next one will take place on June the 8th in the year 2004, and if the weather is bad, you can take the next one in 2012 on June 6th.
Dr. Engelbert J. Schücking is professor of physics at Washington Square College of Arts and Science of New York University. For your assignment, please read Chapter 6 in Highlights of Astronomy by Walter Bartke. For the book lists for the Sunrise Semester courses, please write to Sunrise Semester, New York University, New York 10003. New York University's participation is made possible in part by a subvention from the Sperry and Hutchinson Company. This program was recorded. This is CBS,